In today's video, we'll be learning how to solve quadratic equations. Easy quadratic equations and hard quadratic equations. So, in order to solve a quadratic equation, we first have to factor a quadratic equation. For example, if you have a quadratic equation such as this. Now, right, so we want to find where this equation here, for what x will be equal to 0 here. Now, the only way we can do that, or one of the only ways, is by factoring it first. So we already know that this factors into x squared, x plus 2 squared is equal to 0. Now, let's just rewrite this so I can make it more clear for you. Now, do you agree that if this, right, this product here ever equal to 0, then the whole expression would be equal to 0, right? Because a product times 0 will always be 0. So, and this quantity here would be equal to 0 when x is equal to 2 is equal to negative 2, right? Because negative 2 plus 2 is 0. And x plus 2 on the right side here is also just negative 2. So this quadratic equation only has one solution. And that can happen anytime if the quadratic equation can be written like this, is in a squared version. Let's try a different example, but with not a square quadratic equation, or it can be written as a quantity squared. Okay, let's do x squared plus 5x plus 6 equal to 0. Now we want to find for what x value, when we plug it back into the equation, will the whole expression be equal to 0. Now, we know that 3 and 2 add up to 5, and the product is 6. So we can write this as x plus 3, x plus 2. Now we've already solved the equation, right? We've already mostly done the hard steps. Now, if you're kind of confused on how to pick out, like, picking out one product and how to make it equal to 0, you can always just do this also, right? X plus 3 equal to 0, x plus 2 is equal to 0. So once you factor the equation, take those two products and make them each equal to 0. And if you're kind of confused on what I said earlier, now you just solve each side, right? So subtract 3 on both sides, you get x is equal to negative 3, and x is equal to negative 2, and that's your answer. Now, if you're like, want to check your answer, all you have to do is plug these two answers back into the equation above. Right, so we'll do negative 2 squared plus negative 2 times 5 plus 6. Negative 2 times 5, okay. Right, so we get 4 plus negative 10 plus 6. And this equals 10 minus 10, which is 0. Now let's do the same thing for x is equal to negative 3. So negative 3 squared plus 5 times negative 3 plus 6. This is 9 plus negative 15 plus 6. And this is equal to 15 minus 15 is equal to 0. Yeah, so we proved that both solutions work, since when you plug it back into the equation, it equals 0 right here. Alright, now let's do a much harder example of solving quadratic equations. So say, for example, right, this whole time we've been solving quadratic equations where the coefficient of the x squared term is always just 1. Now, what if the coefficient is 2x squared, right? And then we'll always make up an equation that we can solve here. Plus, plus 3x. Hold on. Let me think of an equation here. Oh yeah, we'll do plus 5x. It's a better equation. 5x plus 3. Okay? So how do we solve this? Well, in order to solve these types of equations, we can either factor out the 2, or we can times the 2 by the coefficient at the end. However, here we cannot factor 2 because we have odd numbers in the equation, right? If you factor the 2, it would be 2 times the quantity of x squared plus 5 over 2x plus 3 over 2, and that wouldn't really be helpful towards us. We can do it that way only, but it would be kind of non-efficient. So a more efficient way of doing this would be 2 times 3. Okay, and when we do 2 times 3, right, we get 6. 2 times 3 is a 6. Now, it's the same problem here. What two numbers, when you times them together, will give you 6, but when you add them together, will give you 5x. Now, so again, you times the coefficient, right, of the biggest term, and then you just apply the same rules to the product of the coefficient and constant, and you get 6, right? Okay, now you get, if you think about it, you would get 2 and 3. So you would rewrite it like this. Sorry, I put the equals 0 there. You rewrite it like this. And we're allowed to rewrite it like this, right? Because 5x is really just 2x plus 3x. And we're not really changing in any way through algebra or anything. Okay. Now, we're going to be using a method called factoring by grouping. Factoring by grouping to solve the quadratic equation. Okay? It's basically where you factor this group first, and then this group here. Okay, so 2x, right? How do you factor 2x squared plus 2x? Well, you just have to pull out a 2x, and then you get times x plus 1. How do you factor 3x plus 3? Well, you just have to factor a 3 out of there. You get x plus 1. Now, after we do this step, we take 2x, right, whatever's timesing the quantity in the parentheses, and then the 3, whatever that is timesing in the the quantity in the parentheses, and we rewrite this as 2x plus 3 times x plus 1. Now, why are we allowed to do this? Well, say for example, right, let's just make x plus 1 here, each of them a. Okay? Okay, so we can imagine a as x plus 1. And we can imagine a as x plus 1. When we add these together, 4x and 3a, sorry, 4a and 3a, you would get 7a. We're doing the same thing over here, except the 2x, we don't know the number, so when we add it to 3, that's why it looks kind of a bit funky. But it's essentially the same idea you're doing here. Same idea. Okay. Now, it's the same idea again. You just put 2x is equal to 0, and x plus 1 is equal to 0. And you solve them. So then, x is equal to negative 3 over 2, and x is also equal to negative 1. So these are our answers right here. Thank you, and I'll see you in the next video.